So in the potential energy, we already discussed, in which we have discussed like potential of energy of a two-point charge system and the combination of charges and the potential energy in the scalar quantity, and we have calculated some potentials. So capacitors, and their form. So Kulsum, is it your first class?
Yes, sir, it's my first class.
So we are just starting the new topic, capacitors and their combinations. So it will not be an issue to, this is not linked with the previous ones. So if you have any doubt in the previous classes or in the moments. So first, capacitors and their combinations. So first we will discuss what is a capacitor. So we know that already we have studied it, basic lecture, that capacitor is a combination of conductors and like. So I will give you brief some basic idea. Then we will go forward. Suppose we have two conductors. So generally, what we have the setup in mind is that for capacitors, the plate must be of parallel shape, or some kind of, we have a shape in mind. It should be parallel plates or something square plates. So that is not mandatory. The conductors can be of any shape. So any shape of conductors can form a capacitor. The thing is that they should be placed close to each other, and there must be a insulated between the conductors. Like here we have conductors A and B. They are placed close to each other and they are charged, so they can also form a capacitor. Suppose air is in between these two conductors and charge on each conductor is Q. Suppose here we have plus Q charge and here we have minus Q charge. So this combination of conductors we can form the capacitor. So the charge given to each of the conductor will be proportional to their potentials, where is the potential difference between the conductors, and Q will be equal to C. So basically here C is the capacitance, right? So it depends upon geometry of the conductors. It depends upon geometry like dimensions, length, breadth, and all these things, and the medium between the conductors. So generally, like from this expression, we might think that it's C is equal to Q by V. So we might think that charge is changing, potential is changing, then capacitance may change. But actually, this is not true. It will not depend upon, it is independent of charge and potential. If you're changing the potential, that will be changed due to charge of the conductors. So the ratio will remain same. Getting my point? So increasing or decreasing a charge cannot change capacitance. Understood?
Yes.
So It will
Yes,
only
sir.
depends upon geometry. So if someone asks you like if we are changing potential or we are increasing decreasing charge, what will be the effect on the capacity? So unless otherwise geometry has been changed, it will only given like we are increasing separation or dimension, then and only the capacity will change. Or if we are changing the medium between the conductors, then and only the capacity can change. So this is the basic idea. Apart from that, we have some kind of capacitors like types of capacitor if we see types. So the uh, most common is parallel plate capacitor. Parallel plate capacitor. In this, what should happen is what is the parallel plate capacitor is like generally what we know like two, we have two conductor plates is parallel to each other and the charges are equal like this plus q minus q and we have some separation between the plates and their area is suppose A. So such type of a combination forms a parallel plate capacitor. The plates should be parallel. It is not mandatory that plates should be square or rectangle. It like maybe circular plate like spherical plates can also form a parallel plate capacitor. Like we have two spherical shells of radius R1 and radius R2. And such combination can also form capacitor. So charges on the place must be equal and opposite. That is the thing. And so it is not mandatory that the plates is square or rectangle. It may be spherical or a cylindrical. Like panel capacitor, this is first type. You see like type A, like type B. This all comes under parallel plate capacitor. We may have cylindrical types. This is also a parallel plate capacitor. Like this. Their plates are also parallel, but shape is similar. This is also come under parallel plate capacitor, but the shape is cylindrical. So this is third type. Here we may have discharge on inner plates and minus charge on outer inside. So this is cylindrical. This is spherical. So such type of combination is parallel plate capacitor. We already know some capacitance like for this we generally know C is equal to epsilon naught D by D, or if the medium is changed we may have capacitance like epsilon naught D by D if the medium is apart other than air, so we have to multiply by epsilon naught. For cylindrical capacitor like if inner radius is suppose inner radius is A, outer radius is B, then its capacitance is C is equal to, we can derive it, so I'm not going into derivation. You have to remember it directly. Suppose length of the cylinder is L, so 2 pi epsilon naught L divided by L B upon. So this is the capacitance of cylindrical capacitor. If we talk about spherical capacitor, so suppose outer radius is R2 and inner radius is R1. So for a spherical capacitor, the capacitance is spherical. It's like 2.7 naught R2 R1 equal R2 minus Suppose the outer radius is R2 and the inner radius is R2. So here R2 is greater than. So for that, here we are giving epsilon naught. It means medium is air. If medium will be other than air, then we have to multiply by epsilon. Any doubt till now, both of you?
No, sir.
No, sir.
Okay. So this is the capacitance of it. And the thing is that the charge must be confined within the plates only. It should not be outside. For a capacitor, charge must be between the plates only. The special cases like suppose there is a single sphere having radius r, so it can also form a capacitor. Suppose charge on this single sphere or a spherical conductor. Suppose this is a conductor having radius r, then it is also a capacitor and its capacitance. So you may wonder how it is a capacitor. There is no two plates. It is only a one spherical conductor. So for such cases, we can assume that the other plate is at infinity. For this case, you can assume that other plate is at infinity, or you can say that R2 tends to infinity. So here, from this expression, we can find the capacitance like this. C will be equal to 4 pi epsilon naught. What we will do, we will divide numerator and denominator by R1, R2. So we make it like here, we make it 1 by R1 and 1 by R2. We can rearrange the expression like this and putting the value R2 equal to infinity and R1 equal to R. Here we will put R2 equal to infinity and R1 equal to R. So we will get the capacity like this 4 pi epsilon naught 1 by R minus 1 by infinity, and that will be equal to 0. So we will get 4 pi epsilon. Understood? So capacitance of a single conductor having radius R is 4 pi epsilon naught. Here in all the expression, you can see that we have nowhere you will find charge in the expression of capacity. Anywhere you are getting potential or charge in the expression, no. Only geometric things are there. A, B, L, these are geometrical things. So nowhere you are getting charge in the expression of capacity. That is why capacitance is independent of charge or potential. It only depends upon geometry. Understood?
Yes, sir.
Okay. So this is the basic idea of the capacitance. So we will do first some basic questions based on capacitance. Then we will move forward. So coming to question. There was one more question. So are you getting the thing, Kulsum? Are you preparing for NEET or JEE?
NEET, sir.
For NEET. So actually on basic, no question has been asked in very basic question based on this concept. So I will give you one introductory question, then we will, so let us see like suppose we have a capacitor like this, and its capacitor, suppose we have a parallel plate capacitor and its capacitance is C. We have not given any, you know, D or something, the area of two. So what happens is its separation is changed from D to 2D. Suppose we have changed the separation between the plates from D to 2D. So we have to find percentage change. Find percentage change in capacitance. Find percentage change in capacitance. Getting my question? There is a capacitor having capacitance C, and the separation between the plates is changed from D to 2D. So we have to find percentage change in capacitance. So both of you try this question. This is very basic question based on capacitor. Then we will do some concepts. Then we can do NEET and JEE questions. Both of you understood the question?
Yes, sir.
Yes, sir.
Anything? Are both of you trying this one? Any answer? Any clue how to solve this one? %, decrease in capacity. So let us see how we get the change. What happens actually? I will do this only here. Suppose initial capacitance C initial is C. What will happen when we are increasing the separation? We know that C is epsilon naught A by D. What is the capacitance? Epsilon naught A by D. It means C is inversely proportional to D. So when D becomes 2D, capacitance becomes C final will become C by 2. So what is the percentage change? Percentage change is delta C upon C. Means C final minus C initial upon C initial. So what is C final? C by 2. C initial is C and C. So this we will get 1 by 2 minus 1 upon 1 means 1 by 2. It means 50%. So the capacitance will decrease by 50%. Any doubt in this?
No, sir.
Easy question. Only we have to see the change in capacity. Understood, Kulsum? Maharaj?
Understood, sir.
Okay. Going forward, now this is very basic question and basic idea of capacitance. Now we will have little advanced ideas. Suppose we have two plates like this. Uh, suppose there are two plates. This is one plate having charge Q1, and there is another plate having charge Q2, and placed close to each other. So this is actually we will see distribution of charge between plates. Distribution of charge. So when two plates are placed close to each other, how charge is distributed? So what will happen is if charge on first plate is Q1 and charge on second plate is Q2, so charges will redistribute themselves and the charge will be redistributed like this. On outer surface, we will get charge Q1 plus Q2 by 2 like this. Charge on outer surface of both the plates will be equal, and charge of inner surface will be equal to this Q1 minus Q2 by 2. Here we will also get opposite charge, that is Q2 minus Q1 divided by 2. So charges redistributed like this. When two plates having charges Q1 and Q2 are placed close to each other, charge gets redistributed. Charge on inner surface is Q1 minus Q2 by 2, and charge on outer surface. If you see charge on this outer surface, on both the outer surfaces always equal, and on inner surfaces, charges are equal and opposite. So what happens in capacitor is in capacitor arrangement, what we have is charges are equal and opposite. So this is the general case for two charged plates close to each other. And when we have a capacitor, then charges are equal. We know that for a capacitor, charges must be equal. So what will be charges? We can see here. If you put equal and opposite charges on the two plates, it means here we have to put Q1 equal to plus Q, and here we have to put Q2 is equal to minus Q. So if I am putting these charges in this expression, what will happen is charge on outer surface will become 0. Q1 plus Q2 will be 0. So on outer surface, there will be no charge. And inner surface, what we will get? Q1 minus Q2 by Q. It means it will become plus Q and it will become minus Q. So ultimately what happens is, and this is the case of a capacitor we have seen. So in a capacitor combination, charge on outer surfaces are 0. And in between the plates, it is plus Q and minus Q. So this is we have already seen. So ultimately what happens when you put equal and opposite charges on two conductors placed close to each other, charge will redistribute themselves and it will come to inner surface. There will not be any charge on outer surface. Ultimately, it will come to inner surface. Understood this one?
Yes, sir.
So this is what happens in a capacitor. So any doubt?
No, sir.
Okay. So also apart, we will do first a question of JEE main based on this. Then we will move forward. So let us do one JEE question based on redistribution of charges. Then so see this question number 2. This has been asked in JEE main 2019 session 2. This question has been asked. So this is basically based on redistribution of charges, what we have just studied. So all of you try this question, then we will discuss it. So do this question number 2. All of you trying this question?
Yes, sir.
Yes, sir.
So also got 1 volt. So let us try it. We have so according to the question, a parallel plate capacitor has 1 microfarad capacitor. Capacitance is given One of its plates is given 2 microcoulomb charge and the other is given 4 microcoulomb. Then we have to find the potential difference developed across the capacitor. So generally what we do is we apply the formula Q is equal to CV, and so here the problem is what to take Q, the charge on the capacitor. Here if you see in the question, what is the charge? Charges on each of the plate is different. So what is the value of the charge we should take? That is the main thing. Capacitance is given and potential difference we have to find. So we have to go through the same concept of different charge Q1 and Q2 on the plates, what we have just studied. What is the charge inside the plates? Q1 minus Q2 by 2. So in place of Q, we have to take Q1 minus Q2 by 2. So we'll put the values here. What is the value of Q1? We will take Q1 as a greater charge. So 4 minus 2 divided by 2 equal to C. What is the C? 1 microfarad, microcoulomb and microfarad will be cancelled out into 1. So from here what we will get? 2 upon 2 equal to V. So we will get V equal to 1. So Kulsum, you were right. The correct answer is 1. Have you done the same way?
Yes, sir. The same.
Krishna, where you go wrong? What happened?
Sir, I didn't know how to calculate the Q.
Okay, so now understood how to find it. So when the charges are different, if charges are equal, plus Q and minus Q, then it is okay. We have to directly apply Q is equal to C. But when the charges on plates are different, we have to uh, calculate charge like Q1 minus Q by 2. Getting my point?
Yes.
So this way we can get the capacity. All right. Moving to the next concept, that is electric field between the plates and all the things. So electric field between the plates. We know that a capacitor is formed by combination of two plates or have equal charges plus Q and minus Q. So and the charges are like this charge like this. So how to calculate electric field? We know that if there is a point in between the plates, suppose we have a point P, so the direction of electric field will be like from plus to minus, we already know. So the electric field due to minus charge will be also from left to right, and for plus charge also left to right. And we know that electric field due to charge sheet from Gauss law. We know that sigma by 2 epsilon naught is the electric field due to a conducting surface. So electric field due to both positive and negative charges will be sigma by 2 epsilon naught. And since both the fields are in same direction, so the net electric field at point B will be calculated by electric field into positive plate and electric field into the negative plate. This will lead to sigma by 2 epsilon naught plus sigma by 2 epsilon naught. So net electric field between the plates will be sigma by epsilon naught, where sigma is the charge per unit area. So sigma is equal to Q by A. Understood this one? How we calculate electric field between the plates? That is sigma by epsilon naught. And sometimes we have been asked like find the force on the plates of the capsule. You know, if you will place the plates like this, these two plates will attract each other and they will collapse. So to form a capacitor, So must, the plate should be bonded with something. So actually force acts between these two plates. This will be attracted by negative charge and this plate will be attracted by positive charge. So how to find the force between the plates? Force is given by electric field into charge. So while calculating the force, we have to take the electric field of the one plate only. Due to its own electric field, uh, a plate cannot exert force due to its own field. So we have to take only force is equal to charge into electric field due to one plate only. Like if we are finding the force on the positive plate, we have to take electric field of the negative plate only. So this will be Q into electric field of the negative plate is sigma by 2 epsilon naught. So the force will be Q into sigma by 2 epsilon naught. And if we put the value of Q like sigma is Q by A, so it will be 2A epsilon naught. So it means the force will be Q square by 2 epsilon naught. So this will be the force between the plates. Understood this one? What is the force acting between the plates of a capacitor? Q
Yes,
square
sir.
by 2.
Yes, sir.
All right. So this is the expression for electric field as well as force. Apart from that, we also know something like electric field density between the plates. What is that? What is the electric field density between the plates? Can you say energy density or electric between the plates? So, and first we will see energy stored in a capacitor. Energy stored. What is the energy stored in a capacitor? There is electric field between the plates, so there must be electrostatic potential energy between the plates, and charge on the capacitor is Q, potential is V, so we know that energy stored in a capacitor is Q square by 2C or half CV square. Getting my point? Or we can also write it like half Q into V. These all are expression for energy stored in a capacitor. So if charge is same, you can use this expression. If potential is given, you can use this expression, or we can also use half Q into V. Energy density between the plates, that is U equal to energy per unit volume. Energy per unit volume, which is half epsilon naught E square. You may have heard about this, half epsilon naught E square. This is the energy density. This is called energy density. Energy density in the electric field between the plates. So energy stored in a capacitor is Q square by 2C or half CV square or half QV, and energy density is half epsilon naught. This both of you, I think this you know the formula, already know the formula. So this is the basic idea of energy stored. Then we will do some question. Apart from that, the important thing is effect of dielectric. So both of you know this one, energy stored in a capacitor. Also, Krishna.
Yes, sir.
All right. So moving forward, we will see effect of dielectric on capacitor. Effect of dielectric. That is the very important thing. Effect of dielectric. What is the effect of dielectric? There are two things. Uh, with without battery, you are in the, like you have a capacitor. Suppose we have a capacitor which is fully charged. And what happens is you insert a dielectric between the plates. You insert a dielectric between the plates of the capacitor. So this is without battery. Without battery. Battery is not connected. And sometimes we insert dielectric with battery. Like you have a capacitor, plus charge and minus charge. So what happens is you insert a dielectric between the plates, but battery remains connected. Suppose you have a battery of potential V connected between the plates of the capacitor, which is plus Q, minus Q, potential is V naught. And what happens? You insert a dielectric between the plates. But battery remains connected. Here battery remains connected. So we will see what the changes in different parameters in both the cases, with battery, without battery, sorry, and with. So first we will see capacitance. What will happen to capacitance? If initial capacitance is C naught, capacitance will become C is equal to Kc. If dielectric constant of the dielectric is K, the new capacitance will increase and capacitance will become Kc naught. Here also the capacitance will be Kc. So capacitance will increase in both the cases. Now, if we talk about charge, if initial charge on the capacitor is Q naught, so charge will remain same. Charge will not change. Charge on the capacitor will remain same. Here, with battery, what will happen? Charge will not be same. Charge will decrease and charge will not be same. Charge will become Q. May increase or decrease depending on the situation. What will happen to potential? Potential, if initial potential is V naught, here potential will decrease V naught by K. So what happens when you are inserting a dielectric without battery? Then what happens is charge remains same. You always remember that charge is conserved. So when you are inserting a dielectric between the plates of a capacitor, charge always remains same without battery. But when you are inserting with battery, then what happens? Potential remains same. Since battery is connected, so potential remains same. Here potential will remain same. So this is very important. In first case, charge will remain same. And when battery is connected, potential will remain same. Here, potential will decrease. We have seen in first case, potential decreases, V becomes V naught by K. Now if we talk about electric field, here electric field will decrease, E will become E naught by K. Here what will happen to electric field? Since battery is connected, potential is same, so electric field will remain same. So here potential remains same, electric field remains same. In first case, without battery, electric field decreases, charge remains same. Understood till now? Any doubt, please ask. Understood the difference?
Yes, sir.
So
Yes,
with
sir.
battery, without battery, you just remember one thing. Without battery, charge is conserved, charge will remain same. With battery, potential will. The capacitance will increase in both the cases. If you are inserting a dielectric, capacitance will becomes 8 times. Electric field will decrease in first case. Electric field will remain same with battery. Potential will decrease in first case. Potential will remain same with battery. Apart from that, we have energy. You know that what is energy? E is equal to, you can say like Q square by 2C. So here capacitance is increases. So what will happen? Energy will decrease. U will become U naught by K. Here what will happen to energy? We know that energy is half CV square. So here capacitance increases, potential remains same. So here energy will become K U naught. Means energy increases. Understood this one? So this was the case for a dielectric when a dielectric is inserted with, you know, uh, completely filling the gap between the plates. So this is the simple case when the dielectric is filled between the plates of a capacitor and it completely filling the space between the plates, right? There is also case we will see
Sir,
further.
can you explain that potential energy again?
Potential energy. Here you see in first case without battery, we know that potential, what is potential energy? Q naught square by 2C. So here charge remains same, right? Here charge remains same. This is same. And capacitance increases. What is capacitance becomes Kc. So here potential energy will also become Q naught by K. Getting my point?
Yes, sir.
In this case, here we know that potential energy is half CV square. It remains same. Capacitance increases K times. So potential energy will become K. Understood this one?
Yes, sir.
Okay. So based on this, we will do some questions based on dielectric. Then we will see partial filling of dielectric. This is the case of completely filling a space between the plate. There is also cases when we fill the gap between the plates partially. That we will see later. So first here we will see some basic questions based on uh, completely filling the gaps. To see very basic question. Question number 34. This is NEET 2010 question. Both of you try this. Very easy. So Krishna says decreases. Kulsum, what is your answer? Yes, it must decrease. Both of you are right. So here, actually, what happens here? Dielectric is inserted. So we know that this is the case of a capacitor. So we know that the electric field between the plates is given by sigma by epsilon naught. So when dielectric is inserted, E becomes E naught by K, right? It means electric field decreases. Very easy question. The correct answer is D. Okay, moving to the next question. Both of you try this. This is NEET 2015 question. Both of you try this one. So Kulsum got C. So both of you got C. So yes, C is the I think correct answer. Uh, if you see, we have to find the incorrect thing. The incorrect, we all know that the charge the charge on the capacitor is not conserved. This is the case of a parallel capacitor of capacitance cell and then disconnected. It is the case without battery, right? So we know that without battery charge is conserved. So without going to the other options, we can directly see that this is not correct. So C is the correct answer. Don't need to, even we don't need to see other options. But if you see for the sake of knowledge, we can see that like energy stored in the capacitor decreases. We have already seen that U is U naught by K. So this is the correct one. The change in energy, we know that delta U, we can find delta is U naught minus U. It means U naught minus what is U naught by K. So the change in potential is U naught 1 minus 1 by K. What is the value of U naught? Half CV square. So half CV square 1 minus 1 by K. So this one is also correct. This is not correct. C1 is the potential difference between the plates. The potential difference between the plates. Actually, this option was the potential difference between the plates uh, decreases kind of thing. The potential difference between the plates decreases. So decreases K times. Actually, the option is missing. It is the potential difference between the plate decreases K times. So this is also correct. We know that potential difference between the plate decreases K times. So the correct answer is C. Okay, so this was the case of insertion of a director. All right, so this is we have done. Move to the next question. We have completion capacities. Okay, so this was the concept related to uh, capacitors, and let us see one more question. I would like to see question. So both of you try this question 34. Both of you try this question number 34. This is not NEET 2010 question.
So we already did that.
This one.
Yes, sir.
Oh, sorry, 34. We have did this. Okay. There is another question. Not this one. This one, 37. Try this question number 36. So question about D. Question about C. So let us see what is the answer. The question says a parallel plate capacitor. A parallel plate air capacitor is charged to a potential difference of V. So we have a parallel plate air capacitor like this and charged to a potential V. Alright. After disconnecting the charging battery, so it must be connected to a battery. Then and then it is suppose the charge is Q plus Q and minus Q. After disconnecting the charging battery, the distance between the plates of the capacitor increase using insulating strap. So what happens is, now we disconnected the battery and distance between the plates increase. So suppose this is D, so now it becomes D dash. So D dash is greater than D, and there is saying that using insulating handles, it means charge remains same. No other charge has been given, right? So charge remains same. Okay. So as a result, the potential difference between. So obviously, what will happen? Charge will remain same. So Q initial will be equal to Q final. So and battery is disconnected. So C1 and Q initial is, so we have as a result potential difference between the things. So C1 initial potential is suppose V1 and C2, or we can say V2, right? So what will happen? V2 will be equal to C1 V1 upon C2, or we can also say that V2 by V1. V2 by V1 is equal to C1 by C2. And what will happen to capacitance? Distance decreases, distance increases, right? So it means C2 will be less than C1. Distance increases, capacitance will decrease. Suppose this capacitance is C2 and this is C1. So C1, what will happen to C1 by C2 will be greater than 1, since C2 is less than C1. So here what will happen? V2 by V1 equal to C1 by C2 when it is greater than 1. So V2 will be greater than V1. So potential will increase. So correct answer is C. Understood this one? How potential will increase?
Yes, sir.
So this is how we should proceed. We have to conserve the charge, since here we have given an insulating stand. That means charge will remain same. If charge remains same, we have to do it like this. So this is like understood, Krishna. So
Yes, sir.
the potential will increase. I'm asking a question, like if you see why potential is increasing. If you see here, if you think like in the way of from the physics point of view, here mathematically we have seen that potential increases, right? But if you think from physics perspective or from physics point of view, why potential is increasing? Both of you, any answer? Why potential is increasing actually here? From mathematics point of view, that is we got Q1 is equal to Q2, and like capacitance, uh, capacitance increases, capacitance decreases. So if we see from physics perspective, why potential increases? A battery is disconnected, right? From where that extra potential comes. Getting my point, what I'm trying to say?
Yes, sir.
What will happen to energy? Tell me, both of you calculate what will happen to energy. You add in this question, what will happen to energy? In this case, energy stored. So find what will happen to energy. Suppose the initial energy is U1 and final energy is U2. So find relation between U1 and U2. See what happens. Like if we see U1, what is U1 half? We can say Q square by 2C1, right? Not 2 is already there. So Q square by 2C1. And if we see Q2, what will happen to Q2? U2. U2 is Q square by 2. Here charge remains same, right? Here charge remains same. So Q square by 2 C. So if we see U1 by U2, that is C2 by C1, right? Charge remains same, half of will be cancelled out. And we have seen that C2 is less than C1, right? So this is less than 1. So U2 is greater than U1. Can you see this? Understood this one? Energies in second case will be greater than energies first case. Both of you understood this?
Yes, sir.
Now my question is it not a violation of energy conservation? Why energy increases by itself? Energy is conserved, right? So is it not a violation of conservation of energy? What conservation of energy says? Energy remains constant. Energy neither be destroyed nor be created. So here you can see there is a creation of energy, right? U2 is greater than U1. Means we have created energy. How is it possible? Is it not a violation of conservation of energy? Okay, both of you think about this. This is your homework. You will think about it and I will ask in the next class why this happens. Getting my point? So I will give you time to think about this. Why energy increases? Why it is not a conservation of violation of conservation? Is it a violation of conservation of energy? Or is it in accordance with conservation of energy? Getting my question, both of you.
Yes, sir.
So both of you think about this and I will ask in the next. All right, so moving to the, this is very interesting actually. Sometimes asking JEE all, and somewhere you will see such type of question. So I want you to give some time to think about it, then I will answer. Okay, moving to the next concept. So we have already seen that. We have already got the answer. Answer we all of both of it clear, right? So okay. Now moving to the next concept, we have already seen here is that we were filling the capacitor with, yeah, we were filling completely. We are filling the capacitor with the dielectric completely. Now we will see partial filling of capacitors with dielectric. So partial filling, partially filling. So what will happen? Like suppose you have a capacitor and I have put a dielectric, like I have put a dielectric, a thin dielectric like this, and its dielectric constant is Suppose this dielectric constant is K and its thickness is T, and area of the plates is A and the separation is D. So now what will happen to capacitance? We know that initial capacitance was epsilon naught A by D. So now the capacitance will become epsilon naught A by T minus T plus T by T. This is the formula for partial filling, right? Epsilon naught A by D minus T plus T by Q, where T is the thickness of the dielectric, where T is thickness of dielectric. Understood this one?
Yes, sir.
This can also satisfy the completely filling. In case of completely filling, what happens? T becomes D, right? So you will get the same formula, epsilon naught A by D minus D plus D by K, right? So you will get K epsilon naught A, that is KC naught. Understood this one? So this will also satisfy the completely filling formula. For completely filling, what happens? T becomes D, right? T equal to D for completely filling. So in that case, we know that when completely filling a capacitor with a dielectric, capacitor becomes KC naught. So this formula also satisfies that. Understood this one?
Yes, sir.
All right. So this is the case of partial filling. Sometimes we may have different dielectrics, like I have put different dielectrics of different thicknesses. Like I have dielectric 1 of dielectric constant K1, thickness T1. I also have another dielectric of dielectric constant K2, thickness T2, and so on. I have n number of dielectrics between the plates. Understood my point? And the separation, total separation is D, and the plate area is D. So in that case, what will happen? The new capacitance will become epsilon naught. Same formula will be continued. Epsilon naught A by D minus. We have to add all the thicknesses T1 plus T2 plus T3 and so on. Tn plus T1 by K1 plus T2 by K2. This is in denominator, right? Don't make misunderstood. This is in denominator and so on. Understood the formula. The same thing will be added. In place of T, we have T1 plus T2 plus T. So you can also generalize the formula like this. You can generalize it like this. C is equal to epsilon naught A by D minus sigma T, Ti, I to N, I to N plus sigma Ti by Ki. I is equal to 1 to 1. I can say I equal to 1. Understood this one? So this will be the general formula. Epsilon naught A by D minus Ti. We have to add all the thicknesses, or then you have to do T1 by K1, T2 by K. Understood this formula?
Yes, sir.
So this is how capacitance is affected when there is a partial filling of plates between the partial filling of the capacitor. All right, so this was the effect of dielectric. Now, very important part, that is, let us see one more. Okay. So we will move first to the next concept, that is combination of capacitors. That is very important thing. That is the, I would say, most important thing. Combination of capacitors. So generally questions, most of the questions are asked based on combination of capacitors. So we will see combination of capacitors. Combination of capacitors. This is the very important thing and easiest thing. In combination of capacitors, basically you have to apply your, uh, your concept, or I can say your intelligence, how to solve the given circuit. You know the series and combination thing, but at that time, according to the given question, you have to see how to apply the formula. So combination of capacitors, that we all know. But the thing is how to apply the concept. Every cricketer know how to play cricket, but how the concept of playing cricket is applied by a particular player, that depends. So the thing is that how concept everybody knows. In series combination, what happens in parallel combination. But how to apply those concept in a given question, that comes from the practice. More you practice, more will be you can easily solve the questions. So moving to the combination, basically we have two types of combination, or I would say three types. So very basic is parallel combination. Parallel combination. What happens in parallel combination? We all know. Suppose we have capacitors like this. The capacitors are connected. All the first plates are connected to one point, and all the other plates are connected to another point. So in that case, the capacitor is known as parallel plate capacitor. Here what happens is potential remains. The main concept is, in this case, potential of each capacitor remains. In parallel combination, potential remains. What happens to the capacitance? Capacitance is added in this case, C is equal to C1 plus. If there are n number of capacitors, then C is equal to C1 plus C2 plus C3 and so on. All is added. So in parallel combination, simply you have to add the capacitances and you will get the net capacity. Here the main concept is potential remains same. That is very crucial part. You will only identify the capacitor. Sometimes it is very difficult to identify the capacitors are in series or in parallel. So in that case, this concept will be very useful. That potential should be same. Understood my point?
Yes, sir.
All right. So moving to the next combination, that is series combination. That is also very series combination that we all know. Series combination, what happens? Capacitors are connected end to end connection. So in that case, like capacitor C1, C2, C3, like this. So what happens if charge remains same? Here what remains same? Charge. So charge on each capacitor remains same. And we know that equivalent capacitance for the series combination, 1 by C is equal to 1 by C1, 1 by C2, 1 by C. If we have n number of capacitors, we all know that capacitance is 1 by C1 plus 1 by C2 plus 1 by C3 and so on. What happens for two capacitors? If two capacitors are in series, this is a very important formula we should remember. What is the equivalent capacitance term? C is equal to C1 C2 by C1. This is very frequently used. This formula will be very frequently used. If two capacitors are in series, then equivalent capacitance is is equal to C1 C2 by C1 plus C2. So this is how we find equivalent capacitance in series combination, and the most important part is charge remains same. Your charge on each capacitor. In parallel combination, potential remains same. In series combination, charge remains same. Understood? And the next thing is mixed combination. That is very important. Mixed combination, what will happen? We may have both the combination together. In this combination, we may have, like, suppose two capacitors are connected like this. So this is basically not a new combination, series and parallel, but we may call it mixed combination. Such type of combination is mixed combination. Here you can see these two capacitors are in parallel, and it is three, and it is a series with the third capacitor, right? So in such cases, how you will find C equivalent? You can find it like this: C1 plus C2, and it is in series with the C3, right? So C3 by C1 plus C2 plus. Just through this one, how we calculated capacitance, how you will calculate net capacitance, the equivalent capacitance of first combination. What is the equivalent capacitance of this one? C1, C2. Both are in parallel, right? So their capacitance is C1 plus C2. And this is in series with this one. So we applied the formula of series C1, C2 by C1 plus C2. So this acts as a one capacitor C1 plus C2. Second is this. Understood this one?
Yes, sir.
So this concept we will apply in different combinations of capacitor. So till now, any doubt, both of you?
No, sir.
No, sir.
So based on this, in next class we will do some questions based on combination of capacitors, and we will do different combination, and we will calculate the capacitances, and we will do some J question as well as B question. So this is how we can proceed for capacitance, and this is, I think, say, and one more concept I would like to, some time remains, 2 minutes. Okay. So the other combination is, the other thing is, two things remains this for the concept part. Then mostly in the next class we will do questions only. And one thing is with stone bridge. So you both of you might know the with stone bridge and symmetric cases. So two more concepts are there which I will dictate in the next class. That is with stone bridge and the other combinations like symmetric combinations. Apart from that, mostly we will do questions based on statement. So for today, I'm ending up here. Any doubt, please ask. Otherwise, we can end for this. All right. Any doubt, both of you?
No, sir.
Okay. So we can log off for today. We will continue in the.
Thank you, sir.
Thank you, sir.